All right, guys, we are on to lesson number 3, which is all about adding polynomials. So when it comes to adding polynomials, right, really what we're going to do is we're just going to remove all parentheses and combine like terms, and then we'll write all answers in standard form. All right. Now, I do want to make sure that we recognize that we only combine like terms. Like terms, again, meaning that they have the same variable to the same exponent. All right, just because they both have x's, right, does not mean they are like terms, right? And we've talked about that in previous chapters. But make sure that when you're combining like terms that you're taking the same variable to these with the same exponent, right? And then also, again, make sure that you're always writing your answers in standard form. Now, the reason when we're adding polynomials that we can just get rid of the parentheses that surround each polynomial individually is this reason right here, and let me show you. So in example A, we've got this parenthesis or this polynomial of 2x to the third minus 5x squared plus x, and then we've got plus the next polynomial in parentheses of 2x squared plus x to the third minus 1. Now, really what all of that means is when we are adding polynomials is we really have in front of every parenthesis a number that's multiplying it, and we've talked about that before. Now, the number that's multiplying this, because there's not one listed, really means that it's the number 1. So in front of this, I really have 1 multiplying that, and I have 1 multiplying that. Well, using the property of distribution that we've talked about before, I would multiply every one of these terms by the number 1. But when we multiply each term individually by the number 1, and particularly a positive one, it doesn't actually change anything. 1 times anything is still whatever that thing was. So that's why we can actually just remove all parentheses and solve. So when we look at these and we are adding polynomials, we're just going to remove the parentheses. So this becomes 2x to the third minus 5x squared plus x, and then plus 2x squared plus x to the third minus 1. Because again, multiplying by a positive 1 doesn't change anything. So we just bring everything down out of the parentheses. Now, our next step is we need to combine the like terms, remembering that that means it has to have the same variable to the same exponent. Well, in order to figure that out, I think it's helpful to, again, divide up your terms. So anywhere I see a plus or a minus sign, I'm going to put my slash. So there's 1, there's 1, there's 1, there's 1, and there's 1. So I had a total of 6 terms there. So then I need to be able to identify, all right, what are like terms? So in order to do that, I always just start with the first term. So 2x to the third. I am looking for other terms that have both an x to the third power. It doesn't really matter what their coefficient is, but they do have to have an x, and it has to be to the third power. So I go down the line. Negative 5 has an x, but it's to the second power, so not a like term. Then I've got an x here, but not to the third power, so not a like term. Then I've got an x here, but not to the third power, so not a like term. And then my next one, I have an x, and it is to the third power, so I need to add those together or combine them. Now, when I go to combine them, 2x to the third plus x to the third. Well, I combine the coefficients as they are. Well, the coefficient of this one is a positive 2. The coefficient of this one's not listed, so it's really just a positive 1. So I add those numbers together. So 2 plus 1 is 3, and then I bring down the x to the third. So 2x to the third plus x to the third is just 3x to the third. Then I do the same thing for my next term in line, which is negative 5x squared. So I've got negative 5x squared, so I'm looking for terms with an x to the second power. So my next term in line is an x, but not to the second power. The next term in line is an x, and it's to the second power. So this is a like term. So right here, I've got negative 5x squared plus 2x squared. So now I'm going to forget that they're x squared terms, and I'm going to say negative 5 plus 2. That is negative 3. And now I'm going to bring the x squared down with it. So again, the coefficients combine through addition or subtraction. -5 plus 2 is -3, and then they are x squared is the type of term. Then I practice with the next one. So I've got a plus x here, right? And I need to look, do I have any other terms with just x's? Well, the only other term is -1, so I don't have anything to combine that with, so I bring it down as is, so plus x. And then I bring down the -1, nothing to combine that with, so then we go there. So once I've combined all like terms, then I want to make sure that I ended up in standard form. So is it going from greatest exponent to smallest exponent? Well, x to the third, x squared, x really to the first, but there's not one listed, and then just a number. Just a number should always be at the end, so this is already in standard form. So my final answer when adding these polynomials is 3x to the third minus 3x squared plus x minus 1. All right, well, I'd encourage you to try example B on your own, then check your answer with mine. So again, with when we're adding polynomials like example B, 3x squared plus x minus 6, and then plus the polynomial of x squared plus 4x plus 10, we're really distributing a positive 1, so we can just bring them down out of parentheses. So this becomes 3x squared plus x minus 6 plus x squared plus 4x plus 10. So I bring them down exactly as they are. Now when I do that, all right, now I need to divide up my terms and see where my like terms are. So here's a plus sign, there's a minus sign, there's a plus sign, there's a plus sign, and there's a plus sign. So I've divided up my terms. Now I need to determine which ones are the same. So again, I start with the first term, 3x squared. I'm looking for terms with x, that is to the second power. As I comb through, I see, oh, there's one right there. And it looks like that's the only one. So I need to combine those. Well, 3x squared plus x squared, that's really like 1x squared. So 3 plus 1 is 4, and then they are x squared types of terms. So 3x squared plus x squared is 4x squared. Then I do it for the next one. So I've got positive x here, right? Do I have any other x, just x terms with no exponent listed? I see that I have another one right here, positive 4x. So positive x plus 4x, that's like positive 1x plus 4x. 1 plus 4 is positive 5, and then they are x types of terms. And then my other next term is negative 6. I'm looking for just another number, which I have, which is plus 10. So negative 6 plus 10 is positive 4. So I've combined all my terms at this point that I can, so then I need to look, is it in standard form? So my biggest exponent should be first. It is. My next biggest exponent is next, and then my numbers at the end. So 4x squared plus 5x plus 4 is the result of adding these polynomials and putting it in standard form. All right, well again, I'd encourage you to try example C on your own, then check your answer with mine. So example C, I'm adding two polynomials, so I'm going to bring them down out of parentheses, b minus 10 plus 4b minus 3. I'm going to divide them up everywhere I see a plus or a minus sign. So I've got 4 total terms here. I'm going to start with my first term and check, do I have any other just terms with b to no exponent listed? Well, I have one other one as I look through. It's a positive 4b. So b plus 4b is 5, because this is 1 plus 4 is 5. And then they are b type of terms. Then I've got my next term in line is a negative 10. Do I have any other negative 10 types of terms or just single numbers? I do. This negative 3. So negative 10 minus 3 is negative 13. So last step, make sure it's in standard form because I have no terms left to combine. Well, b is our first term. Numbers should always be at the end because they don't have variables. So 5b minus 13 is all the way simplified down. All right, well, we've got one more example here, example D. I'd encourage you to try that one on your own, then check your answer with mine. So we've got the polynomial of x squared minus x minus 2 being added with the polynomial of 7x squared minus x. The first thing that I want to do is remove the parentheses since I am adding the polynomials, and that is the first step. So x squared minus x minus 2, and then plus 7x squared minus x. My next step, divide up my terms so I can see them easier. So anywhere I see a plus or a minus, put a slash. So there are all my different terms. So then start with the first one, which is x squared. Do I have any other x to the second power terms? I have one other that I see. So I've got x squared plus 7x squared. Well, that's really like 1x squared plus 7x squared. Well, 1 plus 7 is 8. And then these are x squared types of terms. Then move on to my next one. So I've got negative x here. Do I have any other just x terms? Yeah, I have one other, another negative x. Well, again, that's like negative 1x and negative 1x. Well, negative 1 minus 1 is negative 2. And then they are x squared type of terms. And then my last term here of negative 2, I don't have anything to combine that with, so I just bring it down as it is. So last step, make sure it's in standard form. Biggest exponent at the start, smallest exponent. There's nothing on the number, so that's always going to be last. So this is in standard form, so my final answer is 8x squared minus 2x minus 2. All right, well, if you have any additional questions on adding polynomials, please feel free to reach out. Otherwise, you should have what you need to continue on to lesson number 4.